Testing. All right. Too loud. Testing. 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 All right. Hello. See how this goes. So, as per normal, at the title. Oh, it's fine. Okay. So as per normal, I'm gonna start working, and then once I'm a little ways in and more people have shown up, I'll go ahead and talk about what's going on and what the plan is. So Twitch isn't showing me viewer count. What is Twitch doing? Oh, there it goes. Just got on. So the first thing I'm fixing is dumb bug in the lighting. Where do I compute the lighting? It's down here. I wrote this clever code to compute ambient occlusion by looking at the 27 cubes around a given voxel and determine whether they're blocked or not. And the problem with that, this is the old original code I wrote. It's not a new bug. It's always been there, just never saw it with the old textures and the old terrain. 07. The problem with that is that it doesn't pay attention to what direction the surface is facing. So it gathers, it looks at the cubes behind the face to decide how blocked that face is. And that's what leads to that bad ambient occlusion look where the corners are brighter than the surfaces. That's not a good texture for it either. Let's look over the sand real clear. So all along the edges, you can see everything is brighter, and then it gets dimmer away from the edges, which is not physical and doesn't make any sense. So the thing is, to avoid that, you have to actually pay attention to which direction the face is going and only look to see if it's blocked in that direction. And so that's a pain to do here because we just set a single light value for each cube, which is used by all the faces near it. And the reason this is actually dumb is because there's already code in the system to gather light based on the direction that it's facing. How does this work? 0, 0 plus z. Yeah, so it will already do the right thing. It gathers from 4 adjacent things based on the facing, and so that should fix it. So it's just I forgot how this system worked and did a bunch of stuff I didn't need to do. Yeah, now it's got the shadows at the interiors and does not have weird bright edges. Of course, the bright edges actually made it clearer where the edges were, which was in a way nice, but not correct. Now I just noticed the frame rate lurched a little bit when I was starting up, and that's going to be because I've got too many threads. So where did I leave this? Greater than 6, numproc -3, and max mesh worker. Yeah, I don't remember if I talked about this, but there was a comment that I did the math wrong because I for how much memory was going to be needed, because it's actually dependent on max mesh workers, and that'll limit how much total memory gets needed when you're doing stuff. I don't know where that lives. Okay, there we go. Yeah, if we just set that to 24, we could put a bound on how much memory is needed. All right, so let's go ahead and talk about what the current state is and what the current plan is. So last time I just did this really simple procedural generation stuff just to make the procedural gen a little nicer. Did some really dumb trees. The real trees should actually be procedural trees, not just these sort of lollipops with a hole in the middle. I don't even know what they are. And that was just something I could quickly write with cut and paste and stuff. And when I put these trees in, the problem is that the lighting on everything is just computed based on the height field. It doesn't even know that the trees are there. So, because I could compute it more quickly from the height field. So we need to switch that over to paying attention to what's there. Fortunately, that's really easy because I just fixed that bug. So yeah, and that bug had just been there from the very beginning. We still have outstanding the problem that, oh, that's a bug. I know exactly what that bug is, I bet. Well, maybe it's not a bug. That might actually just be what the thing happens to do, but I'm suspicious that might be like at 0, 0. Like, why would you get a... It looks like there are others, though. I guess you always have to get one of... Do you always have to get a weird point like that? Because you can't two-color a map except by checkerboard. Maybe that just would always happen. I would expect it to be more like these patches and never have that kind of boundary. So I wonder if that is a bug. Anyway, so yeah, so the lighting bug was there all along. Anyway, so I have a list of things that I can work on. The main thing I want to do is just fix these lighting things, maybe add the skylighting thing. And then I can skylighting thing, and then work a little more on the procedural gen. Tackle one of the issues right now is that, yeah, and so the memory, I currently memory leak. And it's not even a memory leak, it's just a mesh leak, and I don't handle a mesh memory usage, excessive mesh memory usage. I don't handle running out of memory, and I'm running in 32-bit. But so, and I do want to get to fixing that. It's just going to be a pain. So I want to get something more visually interesting first. So how long have I been working on it? I worked on the STB voxel render library from off and on from January till I released it on April 1st. And OBBG has been streamed. Do I have a link to it on the YouTube thing? No, I don't. But you can go to the YouTube video of STB voxel render and then find my channel and find the OBBG streams. And that has almost all the work that I've ever done on OBBG. So I think it's probably 10 to 20 hours so far. So yeah, so one of the things I want to do, so work on the procedural gen. The issue right now is that the trees are on this jittered grid, but the grid is still really overt. And I asked in the stream before if anyone knew of a better method. So here you can see that there's this path here that if I just stay on this thing, I'll never hit a tree trunk. There can't be a tree trunk on this because of the way the jittering works, to avoid putting two trees too near each other. It's hard for me to actually go straight down it, so I probably lost it while I was, the other side, but you'll have to take my word for it. So yeah, so I wanted to work on procedural gen, a technique to doing the trees that doesn't have that artifact and is a general trick that I will use for many things, and talk a little bit about how I did this for the city and ZMC. And that's probably worth doing just as a foundational thing. And while I'm at it, there's this issue right now that I'm doing the lighting when I build the chunks. So there's two steps. I build the chunks, and then I build the meshes from several adjacent chunks. And one of the things when I build the meshes is I have all of the neighboring chunks immediately around the mesh. And so if I want to do lighting where I gather from neighbors in some way, which I actually want to do for skylight, I have this problem where in this code I had to pad around the border and generate extra data in the chunk just so the chunk could do the lighting. It didn't need it for anything else, just to do the lighting. So if I do the lighting in the chunk, I'm going to have this problem, and it makes the chunk coding annoying. It has to redundantly generate some data that's in another chunk. I can't make it depend on the other chunk because it's trying to build chunks and they can't depend on each other because that's an infinite dependency. So I'm thinking I'm going to move the lighting actually into the mesh code. In the long run, like if you did Minecraft style where you place these lights that cast light around them, that might live in the chunk still because the lighting there depends on adjacent chunks, but in a different way. The chunks have to have already been generated, but now they're like relying sort of on the disk load path or something. So maybe that wouldn't happen until after disk loading is in, so that the disk load can save these artificial lights. And the skylight could either be cached somehow, or we could just always recompute it when we do the mesh. And the whole thing that's nice about skylight is basically can compute it top down. And since I actually currently happen to be building right here the mesh data top down, that makes it possible to sort of propagate the skylight down at the time. And I have access to all of the neighboring chunks, so I can allow the light to smear out a little bit to neighboring chunks and work correctly. And so there are no chunk artifacts at all. So I probably won't do some of that kind of stuff, but I do want to tweak the lighting and take advantage of not having the lighting in here. So right now, the lighting is still in here, but I no longer depend on my neighbors. And so that's what I want to stick with, is I'll leave the lighting in here for now, just have it not depend on the neighbors. And because of that, I can get rid of all this +4 crap that I was saying I really need to figure out how to, I need to wrap it in some way so it's not all hard-coded +8s and +4s. Now I can just get rid of it. So it doesn't matter that I never introduced the abstraction. And I didn't know that at the time that I wasn't introducing abstraction. I just, at the time I was just being lazy. So anyway, that's the overview of what we're doing. So, and now at the very beginning, I fixed the bug with where I've forgotten how the lighting system in STB voxel render worked and was making it jump through very unnecessary hoops. Hoops that you really can't get the correct results with. So, I should probably just be searching for +4, shouldn't I? It's probably better that I read all the code though, just in case there's something else going on. So I don't miss them. And now, since I don't have to have these extra borders around it, I can do things that align exactly. So because I like had this thing originally where I was like having the chunk biome stuff be computed at the corners of the chunks and interpolated over them. But that had the problem that now when I wanted to compute the biomes for the edge things that actually technically lay outside the chunk, but that I was forced to compute anyway, that made that biome code uglier. So so now I could have that sort of simple biome code again. All right, is that everything? Nope, there's one. Okay, now the problem is here we're still using the height field, but let's just make sure that works, and then we'll switch the height field. Switch it from testing the height field to testing the grain, which is a very simple change now. Because now we're just checking, is this block occupied? Which is what? Build column is saying what? GCP block of J of I of Z. So it's just star like ++ equals 0 to 255. And then Z limit, we don't really need this info anymore because it makes this code a little bit faster, but this is kind of unnecessary. What was this? Oh, I see, yeah. Let's see, are we filling all of this in order? We go Z, then I, then J. So yeah, so we're traversing it all in order, which would be nice for the caches and everything. And now is the lighting still correct? Be unchanged. Yeah, it looks correct and unchanged over here. And now over here, these trees should actually have a little lighting to them, but you just can't tell with the texture. So yeah. That shows a dark spot in between, but this one doesn't. So do I have a bug? Let's switch everything to the sand texture. What's the easiest way to do that? Where does that even live? I haven't used this code in a while. All right. And let's do that. So we can just comment it out and leave it around. Oh, yeah. All right, so we can see this doesn't match. Like that one has the shadow fully covering it. And then this one, the shadow's only at the bottom. This one has no, or only the shadow only at the bottom, and this one has no shadow. This one has a shadow at the top and is missing one side, so that means I screwed up the conversion. Yeah, that's all non-chunk boundary, and that means I screwed up one of those tests and didn't notice. What were those tests that was in here? Oh yeah, this, you still have to do this. Minus however wide the trees are going to end up being. I think it was 4 before actually. So I guess the right way to do that is greater than equal to -4. So we allowed the tree to go 4 off the edge. And should that be 5 on the other side? I don't know. Okay, so that should fix the tree bug. And this tree is really short, which isn't right. I don't think the trees are ever supposed to be able to be that short. So, and here's another one that's still cropped along an edge. Did I not get both sides of that correct? Should only need to be 2 to be in range, or 1 maybe even. So I must have some other bug here. XTY. Walk over the chunks by 8ths. Offset them. If the offset is within range, then we draw the tree. Oh, but it's only, yeah, it's missing a column, which I could also mean could be the build column test is wrong, but I don't think that's wrong. Yeah, that's not adding 4 or anything. Wonder if there's a 4 or 8 somewhere here that I've forgotten about. I don't think I'm using this variable. Let's see. Mic. All right. Derp. I don't know. I do not know. What would be wrong with the trees and what would be wrong with this lighting? Is this not looking at the same variable? I am doing this weird thing of using different variables. do that just in case. I don't think that could be it, but. Oh, no difference. And they still are truncated. Oh, wow. And that one's even. What? That's just wrong. Okay, that implies that the data just isn't matching across those two chunks. That would be why they have different data, because it's like different height field data. It's up way too high. So when it's trying to compute the data in the chunk next to it, it's just computing totally wrong. How are we computing where the trees go? Is it chunk based or is it just absolute position based? Where are the trees? Here are the trees. Flat noise strong x plus I, y plus j. We're not computing the neighbors. Why are we not computing the neighbors? This is just another old bug, I guess. Oh, right, because this used to be offset by 4 as well. And I thought it was part of that offset. Yeah. Same issue. These need to be still. Okay. All right, that should fix the trees. So yeah, yep, that was just a broken fix. Okay, but now the lighting is still busted. And I don't know why. Is it like only correct in this one chunk and then everywhere else in the world is wrong? Or is it a side thing? Facing this way, it all looks wrong. Facing this way, it's in patches. Do I have a thread problem? No, because they're just both part of the same variable and they're same offset, so I don't think it's a memory issue. What's the odd thumping? Somebody upstairs was making noise. I live in an apartment building, have upstairs neighbors. It's not the first time that's happened. It makes me very sad. Not anything I can do about it. To the point that I've tuned it out and I don't even notice it's happening. Oh, I did also move the mic for a second. But I think that was, it's hard to account for the latency. I have no idea what this bug would be. Am I like, is this logic wrong where I'm, yes, it is wrong. I'm only computing the lighting up to the size of the height fields. So let's just do this. Let's just put this back to the slow way, where we don't try to be smart at all. We use Z0 at all? No, we don't. Let's just do it the simple way. It's slower, but it will not fail. Sorry. Oh, Z segment size. Yeah, okay. So now all the lighting is correct. All right. Now we can put the textures back. It's not even in the room above me. It's actually in the room, the next room over the room above that, but it's enough to propagate all the way through because I have a nice mic. Nope, now it's above me. All right. So, guess I need to get a mic that's better near field, supercardioid or something. Yeah. All right. So. So what we want to do is we want OAA for the trees to be nicely spaced, not collide with each other, and yet be able to land anywhere. So, one way to do that I mentioned, is this really Berlin noise? How can it have such a straight edge here? How am I computing the biomes? Maybe I'm not using Perlin for that. Where do I compute the block type? Block type is coming, from Heitler. Yes, right, which I moved into a function. No, I didn't move it into a function. I just made it here. Calling Perlin noise. Why did my mouse just die? All right. I think I have to put batteries in my mouse. Or maybe it's something else, but putting batteries in will fix it. So I will read the code while I'm looking. Everybody who's a programmer knows what processing is. Okay, that's not probably fair, but probably most of the people on my Twitter would know. Well, certainly everyone I follow. Well, not everyone. A lot of the people I follow on Twitter. Well, that's a useless comment. All right. So, hey, look, that fixed my mouse. So I have no idea what I was doing. Oh yeah, I was confused why that Perlin noise would have such a straight edge there. So there's an interesting other thing I thought about. Yeah, I guess we could at least be critical that we could have at least capitalized the word processing, and then we would know it was a proper noun. I was thinking about the fact there is a bug, which is that this Perlin noise does wrap after every 256 values. And because it's scaled, and it's scaled by up to 256, that means every 65536, it should wrap. And so I'm going to test that by adding a keyboard function. Test that theory that that's a problem. So if I move less than 65536, like if I move over by 1024, then several of the octaves of the Perlin noise will wrap and several won't. There are a few ways to avoid that, and one that's perfectly reasonable is to make the octaves not perfectly synchronized like they are as true octaves. So they don't all wrap around at the same distance, because they, the highest frequency one is repeating every 256, the next one every 512, the next one every 1024. They all will repeat every 65536, causing all of the train to repeat every 65536. Where the heck are keys? Here they are. Let's just do this. Cam lock, is it called? Cam lock. Cam lock gives 0 plus equals 65536. So what I would expect is that the trees will move, but nothing else will. And we'll be able to tell because it has to reload everything anyway, even though nothing will change. So that the train height won't change, but the biomes might change. But the biomes might also repeat on the same pattern. All right, let's try it. See what happens. Oh, and I hit the mesh data limit. So let me pull my view distance in. Now that one I shouldn't hit the mesh distance limit because I should free those meshes because they should fall in the same place in the cache. That's odd. But let me not get distracted by that now. Where is the view distance set? That's in render. All right, let's push this to say 800. Yeah, the issue with how trees really group, yeah, I'm not going to worry about. You definitely would at the edge of trees, they the main thing is that they need to get light. So, you know, at the edge you can have low trees or shrubs or stuff, and in the middle of forests you tend to have taller trees and they only have leaves at the top where they are exposed to the sun. And you could try to do logic like that, because like here I do have access to some info about where the border is and could potentially know that trees are on the border and try to account for that. But you know, Minecraft doesn't. What are people's expectations there? But yeah, I mean, I'm not trying to make Minecraft, so on the other hand, you could argue it would be worth doing. So 3. Yeah, that looks pretty much the same. Let's go again, another 3. Yeah, okay, so now, so if you're curious what happens if I move a smaller amount, so the large octaves change, but the small octaves don't change, we can check that. Let's move by 4096. And that may be enough to make the biomes. So anyway, so what can I do to change that? The easiest thing I can do is I can put the octaves out of sync with each other. Like instead of them being 256, 512, 10, 24, 24, 8, it can be 256, 503, 1079. Basically, if they're kind of relatively prime to each other, then they won't all repeat at the same time until the product of all of them, which will be a very big number. However, that's totally different. Yes, kind of. And the main thing we're going to see is the biomes. And the biome is just using a single octave. So it's just whatever the that repeats at. So maybe this isn't a useful test. Maybe I really need to... Yeah, it's really impossible to tell. So that would be one way to do it. Since I'm doing all these flip multiplies in here, it's not like stretching those out would actually be a problem. So split back to 65536. I don't actually need to test this out because I know it'll work. So float octave multipliers of 8 equals 1.01, 1.03, 1.02, 1.02, 1.0057, 1.111, 1.089, just making up random numbers basically. 1.157. And then we do that times octave multiplier of I could pre-bake that scaling, but it's just not worth it. Yeah. What did I call that? Octave multiplier. The eternal, do you pluralize your arrays or not? Okay, so right. So, hey, look, the terrain is slightly different. I wonder if that big lump that used to be around is still around. Anyway, well, I'll look for that another day. So now I'll hit the key. Oops, hit the wrong key. Kind of looks still the same a little. What is up with all that random changing? I saw that before and I had no idea what it was. I didn't really investigate. That's interesting. Am I getting Z fighting between two slightly different terrains? No. It can't be Z fighting because some of them are totally different. What the heck is going on? Well, these are all hashing to the same slot, I know. I wonder if it's possible I'm still seeing the old terrain. Oh, right. The biome hasn't changed because I'm now still jumping by a multiple of the biome. So I get the exact same biome shape. That's a limitation of the biome only using one octave. So that will have to change. What is that doing? Well, people who love the glitch aesthetic would love this. I'm not particularly a glitch aesthetic person, but and there you can see the triangles. This is very weird. Very, very weird. Anything going on in the stats? I've never updated the mesh building stat. Oops. The reason it animates is because my camera is still slowly drifting. I have this spring system or something on it, so it's just invisibly slowly drifting there. Wow, that sure seems like Z fighting. I guess I should dig under the train and see if I am indeed Z fighting. Or, I mean, drawing. Whoa. Oh. Or it's just float precision issues, because I have moved out by 65536. Which is what, 16 bits? Would I run into that large a problem at 16 bits position? Definitely will need to switch to doubles at some point, or fixed point, to address that. I mean, 65536 is a long way. But even then, why would that cause those weird problems? Like, you can see these triangle artifacts. I don't know what would cause that. So weird. I can't actually get them to appear on the screen stably. They only happen as a creeping thing. Does that mean it's some kind of distance thing, and if I get close it will stop happening? Or is it just certain areas and I haven't... Yeah, it seems to stabilize when I get close. Which does seem like it could be a Z fighting-ish issue. I guess I just should assume it's some kind of Z fighting issue. And I have problems with the precision because I'm concatenating everything into a single matrix and maybe losing precision. Okay, that one I can definitely see it is because there is other terrain behind it that's visible. Yeah. Whoa, jeez. Yeah, it's only happening at the lip of things because that's where you can see the terrain, a bit of terrain behind it. Well, and it just really stopped there. What? It depends on my orientation? Oh, because I've only moved out along one axis. So this must be when I'm like facing probably along that axis that I moved out on. I'm Z fighting. Yeah. Okay. So it's Z fighting with the stuff that's behind it. That's why it's always at the edges of things where there are back faces behind it. All right. Well, that's a bug to solve sometime. Not right now. So that is here. Fix depth fighting when far from origin. All right. Yeah, there's definitely a simple thing. So I do keep isolated the position of the mesh from the camera, and I keep the mesh in world space. And so that does mean that the camera matrix says, hey, move this out, or sorry, it takes the coordinates from the vertices, adds, say, 65536 to the X, and then runs that back through the matrix, and the matrix at the end subtracts it back out. And the thing is that initial add doesn't cause any precision problems because it's 65536 and then just adding integer amounts because the voxels are all their vertices lie on integer, so there's no precision problem yet there. There will be when you go out another 256 times further, around 128 times further. But it could be that then going through that matrix does cause precision problems. And then why the depth values end up jittery like that, I don't really understand, but I guess, yeah, just the Z or W values are themselves imprecise and cause that. So let's see. So yeah, okay, I added that bug notice. Let's push it down the list a little bit. So fix the lighting bug. I did. Oops. That to here. Did I leave out something, or is this actually previous stream correct? One thing is I've been taking these notes just to take these notes, and I will try to propagate them into the YouTube thing, because now I have a list of what gets done in each YouTube video. So do that. Add the skyline, doing the lighting in that thing, but I think not. So I guess I'll do the terrain stuff that I want to do. So how does this work? How are we going to do the trees in a different way that avoids this problem? So I'm going to do this. I don't really want to handmade hero this up too much, but let's see. So the basic idea is that we want to do something a little bit like wing tiles. And this is a general strategy we're going to use for lots of things, unless somebody suggests a better way to do it. It's the only way I've come up with to do things. So we have a chunk that we want to generate. So we're going to basically say that that's a wing tile. So wing tiles are a system where you can pre-author a small number of tiles, and they have edge connectivity rules, and you can place them down pseudo-randomly and get this totally nice looking thing. And that's a workable thing. I think that's how we did Terra Nova in the editor. I think that was how tree placement worked in the Terra Nova. It had like four tiles of tree distributions. But this is going to be fully true procedural, but we're going to borrow some ideas from wing tiles. So the idea of wing tiles is it means you can build a given chunk without knowing anything about the adjacent chunks. You just need to know about the constraints on the edges. So the way in wing tiles it works is that there's a specific color. So you have like this edge of this particular predefined tile might be red. And if it were, then you could only put a tile over here that had a red on the right. And so all you need to do is pseudo randomly generate the colors for the edges. And then you just place a pseudo randomly pick a tile that matches those edge constraints. So doing that with edges is a pain, but actually you can color the corners instead, and that turns out to be even better in certain ways. And the paper that talked about this, so if you trace down all my stuff, you can eventually find my herringbone wing tile paper or papers, and I talk in one of those about the idea in the wing tile things, which was that you had to pre-author, so every corner could be one of two colors, say. So you needed, say, a tile that was red and two corners and green and three corners in these three corners. So you had to pre-author that. And how do you pre-author that? And the way you pre-author that is you define what goes in the corner of the red tile, and it will always be the exact same. So you want to make this circle as small as possible. Every tile that has a red corner is always going to use the content in this tile, so that content will always repeat. And you do the same for the green. So these four, and you can use more colors to make this more varied, but then you need a lot more tiles. So each of these, there's just one predefined green shape. So if we're saying this is how trees go, you might say the tree and a green thing goes there. So that means there would be a tree there, there'll be a tree there, there'll be a tree there. Then you also have to make sure the edges match. And so the way you do that is you say, well, I'm going to predefine, and so then the red might generate the tree there. Then you're going to predefine what happens along the border between a green and a red corner. You just predefine this whole edge shape. So you'll say, here's what this edge shape looks like. We know that the red one generates the tree here. We know that the green one generates the tree here. And we'll predefine that they're trees like that. When you actually go to generate a predefined wing tile, an actual tile, you now have corner constraints that define the edge constraints that all have predefined content, and it lets you fill in content. They have an example of this in the wing tile paper for generating Poisson distributions, which is exactly what Casey's tree branch thing placement was about. So this would be the exact same pattern on both, well, not in this case, it's green and green. And the verticals are different from the horizontals. So I needed to actually pick a case where these would be. But if they were the same patterns, if this were red-green and this were red-green, then these would have the exact same patterns. And this area is the place where you author totally unique content to this tile that's not shared, and you just constrain all the trees that you place so they're not too close to any of the ones in the current ones. There you go. That's high concept of how the wing tile stuff works. And to do this, we just do the exact same thing I said before, but we have an infinite number of colors. Every single corner generates a unique decision about what trees it wants around that corner. And you can independently compute that. So the idea is we're going to compute this chunk, and sometime later we're going to compute the chunk right next to it. We need to make sure they match up, and we can't actually compute the same chunk. But we can't compute the neighboring chunk when we do it. So the way we do it is we randomly generate what goes at this corner, this XY coordinate. We say that's a corner, let's generate that. And we'll generate the same thing for that for either side because it's based on the coordinate there. So say that tree falls on the exact center point. Then for this one, that's a totally different coordinate, so it randomly generates that it wants a tree there. And it doesn't matter, but say this one generates a tree there, and this one generates a tree there. Now we go along each of the edges, and we pseudo randomly generate trees along those edges, and we just make sure they don't get too close to each other or to either of the ends. So there's an edge generator, and maybe you pass in where the two end trees are, or maybe it just regenerates them, because if you just make this corner generator really, really fast, you don't have to cache anything and it'll simplify all the code. So you make this one use a dumb random number generator that's not very good. It doesn't matter. It only appears at corners. The corners are like a very small amount of the total area. So, you know, this one got generated here, and then we generate in here where the trees are in some way. But most importantly for this demonstration, we do it here. We generate where the trees are. And by construction, because these trees get generated totally just based on these coordinates, it will always generate the same list of trees, whether we're on this side or on that side. So if we're just talking about generating this chunk, we do that on all the corners. Each of the edges is constrained by the adjacent corners, so they'll all be correct versus their corners. And then once we've got a list of all the trees around the edges, we can generate trees in the middle and make sure they don't get too close to the trees on the outside. These again are just tree candidate coordinates. They're still the decision about whether a given tree gets generated or not based on the biome. And of course, if you wanted tree distributions to be different in different biomes, you would just have multiple generators of these. Now, what I actually do in most things, in the wing tile one, one thing that you have to be careful about is this edge here. Maybe I should use different colors. This edge, when we generate it, just doesn't know anything about the tile we're generating. It just knows about the constraints placed by the two corners. Meanwhile, this edge, when we generate it, only knows about the two corners. It doesn't know about the other edge or about the contents of the chunks. So there's a risk that this could try to generate a tree right here, and this could try to generate a tree right here, and they'd be too close to each other because they don't know about each other. So when I make the corner look like a circle, that's misleading because that's really terrible. But if that corner is a circle like this, oh, that's a bad circle. All right, there we go. How do you, okay. And then we make one this way. There's actually a spot where they overlap, so this is terrible. So you, at a minimum, actually can't make it a circle. You have to make it a square, which I can just do with this. But at a minimum, it has to be. I have to switch it back to the pencil. So at a minimum, it has to be a square. But then they'll still meet at this corner, and they can collide. So what you actually have to do, the corner actually has to be octagon. If you're making full-on wing tiles, terrible octagon. And then the edge, and the edge, the edge. Now these edges don't quite bump up against each other, and you don't have to worry about collisions between them. All right, so how do we do that in code? So what we want to do is, in the case of trees, you can basically think of them just as edges. So I want to think about what I need to do in terms of octagons here. So basically, I'm going to say there's some radius in which I'm allowed to generate a tree. Like, what is the tree nearest the corner? That's going to get generated by the corner for sure. You know, I could even limit it. I could say it doesn't go more than a couple voxels away from the corner. even if normally the spacing between voxels between trees is say 8, like say the spacing between trees is 8, which I think it is, plus 8, yeah. So the nominal distance between trees is 8, but the random jitter can cause them to be closer. Normally that would mean this should be a 4x4 area that could contain a tree. If I say no, it has to be closer than that, it can only be plus or minus 1 around this, then there will be a dead zone where it's never going to create a tree ever at every corner. However, you're never going to notice that because along the edges, I can weaken that and allow it to generate out further potentially. And then you don't end up with like, so it would mean that if it can only generate out to there, right, it would mean that there would be a line here that you would never get a tree trunk at the corners. But as long as I can generate a tree trunk out there for the edges, it would be okay. However, that runs into that problem I was saying about these things. So I think I can't do that. So I think the corner actually is going to need to take responsibility for a larger chunk. And maybe it should be square instead of octagonal to simplify life. I would do it as an octagon in if I were generating texture. But since I'm just generating points for things to go, maybe the thing to do is, it can generate up to 2 trees, 1 or 2 trees, and then these are allowed to generate trees. And then this whole thing about filling in this hole here, like, oh, that's weird geometry. How do I do that? Well, I'm just trying to place trees and make sure they're not too close to other trees. So if it actually happens to try to generate a tree here, it's okay. It either will be too close to a tree in the corner and be wrong, or it'll be far enough away from all the trees in here that it's allowed to generate, as long as it's not close enough that the tree itself would extend past the chunk boundary, because the adjacent chunk is not going to know about it. Oh my gosh, that you can't see anything in that drawing. So what do I have to do? So that means that this distance okay, and that square. Okay, so here's a corner. Here's the edge. So what can we say? And then here's the chunk boundary. I do have Photoshop also, but it's not really any better for mouse drawing, so so what can we say? Let's use a little blue line to mean the legal distance that trees can be close to each other. So the center is actually going to try to generate trees. The center of the chunk, which is down here, center of the chunk is going to try to draw trees up to this corner. And so if that distance has to be larger than, it knows about everything in here, but it doesn't know about this. This is the only part it doesn't know about. So this distance has to be the minimum tree spacing. Okay, well, that's not too hard to constrain. And then this corner to this corner has to be the minimum tree distance, because that's where these edges will generate without knowing about each other. So corner to corner distance there. Okay, I need to actually do a diagram to figure out the math of this. So let's introduce some. So let's call the half the corner radius corner, C for corner. Let's call the edge to side distance. That was terrible. Edge. Let's call the tree minimum distance M. Okay. So, oh, that actually fits without me dragging anything. All right. So, what do we have? We have minimum M equals minimum spacing between trees. E equals edge generation radius. And C equals corner generation radius. Okay. Then what are the constraints that we have? So one constraint we have is that 2e must be greater than or equal to m. The other constraint we have, that's this edge constraint here. Twice the edge has to be greater than the minimum raise. This one is a complicated one. So that we have to figure out what the xy coordinates of these 2 points are. So it's c in one direction and e in the other direction. So there's a point at c comma e, and then there's a point at e comma c. Distance between c comma e and e comma c must be greater than or equal to m. What is the distance between those two things? It's e minus c squared plus c minus e squared equal to m. So that's 2 times c minus e squared. Well, that's a really weird constraint. Is that actually right? Yes, it is. And the squared, oh, I forgot square root. It has to be greater than or equals m squared. That has to be greater than or equal to m squared. So square root of 2 times c minus e has to be greater than or equal to m. So c minus e has to be greater than or equal to m over the square root of 2. And if we just make that greater than, let's write that out correctly. Square root of 2, which is itself greater than m over a larger number, like 1.5. So by transitivity, we could just use that number. So if we make m, which is equal to m over 3 halves, which is m times 2/3. Is that right? Yes. Okay, so if we make m be a multiple of 3, like say, suppose m equals 6, then we can just work out what that means. M would have to be, or rather that number there now becomes 4. So we have c minus e has to be greater than or equal to 4. That's pretty big. That should be absolute. You can go in either direction. So that would mean that the corner would have to be, say, 8. Well, the edge was 4. That would satisfy, and m equals 6. That would satisfy the constraints. So our chunks are 32 by 32. So how do you clear these days? I don't know how to clear it. Oh, it's probably, oh. All right, that'll work. So I guess I gotta use Photoshop on a grid. I have no idea if there's any way to make a grid in this. Oh, hey, look. How do you set the size of the grid lines? Oh, like they're fixed. Or maybe I'll just freehand it and try to have a sense of how it should be. So if my chunk is 2, 3, 4, 7, 8, 8. If my chunk is 32 by 32, yeah, look at that, how the grid just doesn't even align anymore. Great, useful. Wait, is that not even a matching anymore? Or is that how badly I drew it? I guess how badly I drew it. So if the chunk is 32 by 32, then I have to make the corner be 8 wide. Corner is taking up that much, which is huge. I'm just drawing this so I can understand what this math is telling me to do. Now, of course, I can try to use a different set of numbers, but the C minus E always has to stay that way. So the edges would get narrower. To bring C down, I'd have to make E smaller. So now if I draw this E. So that's the area that gets filled with that one. Let's see, it gets filled with that. Now the advantage is that the corners can generate without needing to know anything about their neighbors. So they need to fill out a pretty large area with a number of trees, but it can use dumb logic. It could use grid jitter, or it could just place a bunch and reject the ones that are too far, but that's kind of slow. So the jitter approach might make more sense. So within a little region, they might be a jittered thing like the current math. Then the edges will generate in this small area based on the ones they find in the neighbors. And then this would just generate and avoid colliding with all of them. Those are pretty big to have to fill in to seed it. So if I tried to pick different numbers, I could say C equals 6, E equals 2. But now the E is so narrow, trees are not allowed to displace very far. They can only displace by 2. That I worry that would produce visible artifacts. Although so would the seeds that are jittering. Is this zoomed once? Is that what it was? Yeah, that was what it was. We do that again. If I tried a smaller C, let's say we subtract 2, how would that really look? That. Where? And these would be skinnier, half the width. Be like that. Or longer this way, because the corners are smaller. So now this would just really, regardless of how it generated, it would just look like a jittered line. Might be okay. And then the fact that this was a jittered thing wouldn't look so bad. But yeah, let's try that. Let's try C equals 6, E equals 2. Already 9:45? Wow, I've taken forever. M equals 6 still. Now, I could also weaken the M equals 6 things, but I don't want the trees to stick together too much. So I guess I can try to do this. I kind of have to stop at 10. I don't really have to stop at 10. All right, so let's see if we can do this. So type F struct tree corner data, type F struct tree edge data, type F struct tree location. Do these need to be in world coordinates? They kind of do. Max trees per corner is going to be, well, if corner is only that doubled, it's 12 by 12, and 6 is the minimum spacing. You can't actually fit more than 4. I think, let's call it 9 just in case I get that wrong. Trees, tree area data. Just use the same data structure for both of these. Tree location, trees, max trees per area. The code for all this is actually going to be pretty simple, I think. So, void generate trees for corner int x int y. So, pick an initial offset, which can be large. So we need a way to generate pseudo random data from a coordinate. So we have flat noise strong, flat noise weak, that stuff. So let's view noise. 8. All bits rate. Is flat noise 8 faster? Why do I have a flat noise 8? I don't remember now. Oh, look, it's commented out. Doesn't repeat for 64K, so your trees might start repeating at that point. Fast noise. Oh, this actually interpolates. We want flat noise, which doesn't interpolate. Flat noise weak. Probably use flat noise weak. Sure. Because we want these to be fast. Flat noise weak. What was the comment about how much data of it was valid? Flat noise 32 weak. All bits random. All right. Noise 32 weak. 32 and 1 equals flat noise weak. X comma y. Random seed. And we could try to shift these right because we know these are always multiples of 64, but the first thing that flat noise does is starts shifting it, so probably little value to it. Yeah, it just starts shuffling all the bits, so really doesn't matter whether those zeros are at the left or the right. So we will say that x equals and mod. Well, if the offset is 6, then this, if we do and 7, kind of bias it, but I think I can live with that. Y plus equals, and should write 3 and 7. And we're going to have to offset each tree by, so if they're spaced 8 every 8, and we don't want them to be nearer than 6, then you can't displace them by more than 2? Which were you displacing by in the old code? Where's the trees? Flat noise strong. Yeah, we are offsetting them by plus or minus 2. So, so you need 5 possible values, and you get that out of bits. So int random 5 of 4 bits maybe is good enough. So the problem is that you can't easily, if you take 3 bits, it'll be super biased. So we'll make a little table here. We'll feed it 4 bits. It's a little less biased. And I guess we'll throw the extra in there. If I went to 32, I would have 2 left over. If I went to 64, 4 left over. And each of those would decrease the bias because there'd be more coming ones. But I think we'll just go with that. So now we need 4 bits for X and 4 bits for Y for each tree that I'm about to do here. And I'm going to do, I guess I'll do it like that. I'm going to do 9, up to 9 trees. So I need 9 times 8 random bits. Gosh, I need a lot of random bits. Can I just use, I only generate 4 instead of 9. Can I be sure that 4 is enough? I guess I can. If I'm wrong, this means I won't get trees at the very edge. Then the other side will be able to generate them there. I guess I can just assume there's 4. There's 4 per corner. There might be more along the edge, so I'll leave this at 6 for now. So when we do this, what we want to do is bias that way and subtract 8. Bias that way and subtract, 6. Okay, so I've gone 6 to the left or above at most. I'm going to do 4 trees. So I only need 32 more bits. N equals flat noise 32 weak. I'll allow it to use the perturbed X and Y to be slightly different. And we'll do that. So now we go for j equals 0, j less than 2, plus j, less than 2, plus I. Now we just want to generate some jittered trees. And tx equals x plus I times 8 plus, let's just do it like that first. Int ty equals y plus j times 8. Tx plus equals random 5 of noise and 15. Noise, discard the bits we just used. Ty plus equals random 5 and 15. Okay. Now we check if they're within the legal range. If tx, except we've offset x and y, so we don't even know what the legal range is anymore. Int base x, base y. If tx is greater than, let's say, define edge tree corner size 6. No, tree core size. Wait, is it really 6? M had to be, oh, it had to be 2/3 of M, right? Define tree min spacing 6. Define tree edge size 2. Alright, so the x is greater than, oh, but that tree edge size doesn't work because that one doesn't satisfy the this constraint. I forgot about that constraint. 2em has to be greater than equal to 2e has to be greater than equal m. E of 2 is not. So this needs to be at least 3, 7. So tree corner spacing 7. Now that 2x2 rule definitely doesn't apply. Definitely can be 3x3. But I can bias towards picking the corners that don't have that behavior. It would only be 3x3 if they were right up at the corners. So what we'll do here is we'll go -6. It's still minus the old amount, so this is just gonna have to be hard coded. So then we say if tx is bx minus tree corner size greater than equal, and tx less than bx plus tree corner size, and ty greater than equal by minus tree corner size, and ty less than by plus tree corner size. We're going to return a tree area data, tree can't be plus equals. And then we add it. Right, so I want to initialize this TAD trees equals 0. And we add a tree. Woohoo! TAD trees plus plus TAD trees. Num trees. I should probably put this in a function because I'm going to need to do it the other one as well. Add tree, data, TAD x y. Location TL equals xy. TAD trees of TAD num trees plus plus equals TL. All right. Add tree tx comma ty. All right. Return TAD. Now, if I've done this all right, given that I just changed these things, it has to be that now. I believe I should always have 4 trees. That test should never fail. Just do that. Is that true? Yeah, you should never fail to fit. Oh, but an individual one could jitter outside corners. So that may not actually be true. So let's not make that assumption. You can never have more, but it could have less. Let's see. So this is going to kind of take a while. Because now I got to do the same for the edges, but now the edges have to know about the corners, and then I have to do it for the whole tile, which has to know about both the corner and the edges. So that may add up to more time than I want to spend tonight. Yeah, but the thing is, you said that subway question. The thing is, you'll still just call the whole thing a subway even if some of it is above ground. But I mean, yeah, they usually have their own name. L, of course, stands for the elevated train, I believe. And yes, you have BART. The Washington D.C. area has Metro. I don't remember. Does New York have a name for their subway? I know you were talking about New York in the first place. We just call it the train. That's from a non-American perspective. Yeah, I know it wasn't directed at me, but I'm reading it. How am I not going to comment when I've lived in? Oh, and what was it called in Boston? What was the other place I lived that had a subway? Boston is the can't remember what it's called in Boston. I definitely had some name. I'll totally recognize it when I hear it. I lived near one of the X stations. I can't think what X was. Anyway, I wonder what it's called in Washington, D.C. I just said it's called the Metro. If you were listening to the stream, you would have heard that. So now everyone else knows that Andy Boy 223 is obviously not listening to the stream, or at least not paying attention. Boston. Can't remember. That I keep thinking of some of the other non-subways in San Francisco. The T, of course. The T is what it's called. I don't know what the T stands for. Transit. And so we're adding a tree. So now we get to do a tree area data, generate trees for horizontal edge. And we'll describe it by the coordinate of the top left coordinate, the smallest coordinates. And we'll pass in, so we don't have to regenerate them, C1 and C2. And I would like to be able to use the same function for these, but they need to swap the X and Y coordinates in their interpretations. And so that's a pain to write in the code. So I'll do vertical edges separately, and I'll either cut and paste and swap, or I'll actually swap the data, call it, and then unswap the data. So, trace, horizontal edge. Yeah, maybe swapping the data will work. And yeah, so I'm passing those in so I don't have to recompute them. Now we have to generate a row of trees and let them not be too close. So, the trees extend from tree corner size. So let's just write this the wrong way first. For x equal, oh, we can't use x. Let's call this edge x, edge y. Then we say x goes from tree corner size, that's the starting coordinate on the x-axis, and x goes up to gen chunk size x minus tree corner size. And then at each of these locations we might have a tree. Again, this is not how this code is supposed to work. This is just me getting a handle on it. Could have just written this as less than equal x less than that. Is really all I was trying to think through. Just did it as code. But not only do the x's regenerate have to obey that, but they also have to not collide with the things. But the only one that can collide are the edgemost ones. This is what I was trying to get a handle on. So what we want to do is decide the edgemost corners of, so we'll x left and x right. So we try generating, let's say x left equals tree corner size plus, and we need a random number. Sizeof with lvalue type in the statement you declare it in. Yeah, I don't know where you're talking about sizeof in any of the current code, but I'd certainly use sizeof all the time in this format. This is a totally standard thing that I do, which is some struct, that's for x equals malloc size of star s. But none of that's an lvalue, so I'm not really sure what that's about either. Yeah, okay, that was the thing he was talking about. Yes, this is totally legal. Size of doesn't require an initialized variable. It doesn't evaluate what's in it. And it's also not, the contents of that aren't an lvalue anyway, so I don't know why you were calling it an lvalue. It's a dereference of the thing because the thing was a pointer and I want the size of the struct. So s is a pointer to a sum struct. Star s is always a sum struct, the type of star s. The sizeof only cares about the type of its argument. It doesn't actually care about the value of this argument. So the fact I'm dereferencing it, even though it's not yet initialized, doesn't actually mean anything. All it is that s is a pointer to a sum struct, star s is a sum struct, and I'm taking the size of that, and that's all it cares about. Because you can do this, right? You can say, I can define a global variable, and that's an array that's size of some other variable, right? And this is evaluated by the compiler. The value of this is evaluated at compile time. And so if this said size of star foo, that's still totally legal as long as foo is a pointer, right? Right, this says foo is a pointer to an int. This is a way of saying this is exactly the same as saying int var size of int, which is obviously a weird thing to use your size of your size of for, but I just wanted that to be clear what it meant. And that's just a conventional that is just a conventional thing that I do, because if I end up changing the size, then the malloc will still be of the right size. If I end up changing the variable name, this will become undefined and throw an error. So changes to this are not bug prone. Whereas if you malloc size of anything else, like the common thing that people used to do was to put the type name itself in here, you could say size of genchunk. Then if you came along and changed the name of the type, you would end up with a size of that was now wrong and allocate the wrong size. So this is a convention that many C programmers use. I don't know if it's most C programmers use, but it's a convention many C programmers use because it is the least bug prone way of allocating the memory in C. So, so I can displace this by a random amount. Let's say n and 3, and then I need to collision check it. So I guess I need y left, y right, because these are going to be y left is, so this has to be ex plus. This is ey minus 2 plus, we used up 2 bits here. Let's just write it this way. This is n and 3 as well. So if collides C1 x left, y left, then we need to choose a different position for x left. So try x left plus equals 2. I'll do this, just do this. And that can't go very far. Assert x left is less than tree corner size, less than edge x plus tree corner size plus min, what was it called? Tree min spacing. And then we're stepping by 2. So probably that is probably valid. Let's see, evaluated from right to left in declaration, which you normally do with AST, so it wouldn't know what type GC is. Nope. Nope, no idea what you're talking about. So I mean, it's not, none of this is evaluated. None of this is a statement. On the left side. In the expression, there's no evaluation order in an expression at all. It's arbitrary. But it's deciding what the things mean, including the types, no, there's no thing about that. The only thing that C has is a left to right rule. In the sort of thing you're talking about, only thing it has is a left to right rule of knowing what a name refers to. So the moment you hit foo GC comma, it knows what GC is. Anything over here can use GC. And you can write this, and some compilers used to let you get away with that, like this one. It doesn't complain about x equals x. X is undefined, so it's clearly bug a statement. It needs to warn about it, but it's not an error. I believe it's not an error. I believe C actually allows that. It clearly should be a warning. I'm using an ancient compiler which didn't warn about it. So yeah, I haven't written collides yet. Then we have to do the same thing on the right. It's ex plus gen chunk size x minus tree corner size. Then we're going to add, I forgot to shift out these bits we've used. Then we're going to add n and 3, so we need to subtract 4 to compensate for that, because we're going inward. Then y right equals UI minus 2 plus n and 3. I don't think, certainly that's been valid the entire time ANSI C has existed. Maybe it wasn't legal in KNRC, but I doubt it. Like, it's possible. But yeah, as of ANSI C, it always worked. And ANSI C is ancient at this point. So then, wow, collides. C2, x right, y right, x right, minus equals 2. Assert x right, great equal, x plus gen, chunk, size, x, tree, corner, size, minus tree, min, spacing, minus 2. Assert x right must be greater than x left. And they shouldn't be within range of each other, actually. So, plus tree min spacing. That's just an assumption that this is a long, skinny thing, so the left end and the right end shouldn't be able to affect each other at all. Now we have to populate the space between them with trees, which I don't know how to do without doing at least a divide. So tree min spacing is 6, but tree average spacing is 8. So the number of trees, I can't actually write this code because I can't declare an int in 6 like that. I don't even know what good somebody else doesn't. Character sheets. Character sheets like a pen and paper role-playing game? What? Is this like a Twitch thing? Whatever. Num trees. So the number of trees, have to be careful about fence posts here, but is x right minus x left over 8. But because of fence post plus 1, and that has to be a minimum 8 for that to work, which is not quite the same as tree spacing. So we'll do that. So num trees is that. And the num new trees, well, we don't actually need what I want to do is then distribute those spaced out evenly. How do I do this? So yeah, I do want the plus. No, I don't want the plus 1. I want the plus 1 so I know that that's what num tree. Here, let's do this. Stupid fence posts. I hate fence posts. I have played DnD many years ago. My older brother and his friends played the original basic, maybe the blue box, not the ancient. I don't remember what you called the ancient one. Mail era one. But the blue box that was like basic, you know, the AD&D, if it stands for Advanced Dragons, and this is like basic Dungeons and Dragons, something like that. So, you know, 70s. Early 70s? How old would I have been? I was 8. Remember now. Would have been older. I would have been 10. I don't know what to call this variable. And that when you're stumped on what to call a variable, maybe that's a good sign to go that you're 4 really that late? I don't actually know when it was, so maybe maybe I should stop, but I guess I should Let me try to go for another 15, see where I can get. Trees. I don't know what to call this. What to call this? It's not quite the left. The trees that aren't assigned yet. It's that. Okay. Well, what am I going to do with this number once I know? Then I'm going to distribute that many trees. Biggest chunk 32, 5 by 6, most 5. Okay. So yeah. So this. And once you subtract out the corners, it's probably actually at most 3. It would actually make this a lot simpler. All right, wait. Subtract out the corner size. Code is not going to generalize if you try to change the chunks anymore. Okay. 32 minus 14. 16, 18. There you go. So in 18, you could fit, just barely fit 4. They went right up to the corners. And the min spacing is 6. 18 row. No, do defense posts, you can't quite fit. So you can only fit 3. That now means that we don't need this because we now know that the last tree hard coded as well. Okay, I might be totally wrong about this analysis, but let's try it. So x mid equals x left plus x right plus n and 7 minus 4 y mid equals same thing, y minus 2 plus n and 3 equals 2 and shift right equals 3. If x mid is greater than, no, if x mid is less than x left plus tree min spacing, then x mid equals x left plus, oh, I guess I'd just be using a function. If x mid x right plus tree min spacing minus tree min spacing, x mid equals x right minus tree min spacing. If x mid still is greater than x left plus tree min spacing, then we can add it. Tree add x mid y mid. But this code just doesn't generalize at all now because that's a super severe assumption about how big the chunk is, that only 3 trees can fit on an edge. Anyway, why are people talking about character sheets from DnD in my chat? Do I want to know? It's not my chat, it's your chat. On the chat associated with my stream. I'm not trying to disapprove, I'm just curious. And then we have to add the other trees because I didn't ever do that. X left, y left, tree. And you know, just because it's kind of nice and pretty, let's do that. Then let's do this raw. Unsigned. Oh no, it takes the seed unsigned. Yeah. Unsigned. Unit 32 seed. And then function. We pass in the seed. It's here. Try to generate trees for horizontal edges. Oh, okay. I much prefer I much prefer Benedict Cumberbatch's theory there. As you wish. And then we have to do the vertical edges, and that is why I did all that mess, was so that I can now use a different seed with the vertical edge. Y tree area data, C1 tree area data, C2. And then we have to swap the edge data, swap tree data, C1 chords, swap tree chords, C2, tree area data, tad. Oops. Then we have to swap them back. Return tad. And these have to be swapped. Or they don't really. They just need to be, they're just random number seeds, so you don't have to swap them. So let's actually not swap them. No, it does use the coordinates. Yes, it actually uses the coordinates to decide where the trees go, so they do need to be swapped. Okay, right. I don't even remember who my other moderator is. Oh, right, him. Since you're the one who told me to make a moderator, so why would I even remember? There's some name you typed in. Nothing personal with Drive. Change names? Was that always your name? Wow, it's weird. I guess it's just been a little while since I streamed, so I don't remember anything. Again, nothing personal. Does that seem right? This doesn't have to be in the reverse order. I just kind of do that for symmetry. I don't need to swap C1 and C2. I think that's right. Okay, then void generate trees for chunk. This doesn't actually need to be a separate function because it's only going to be called by the chunk, but we'll do it this way anyway. And it's going to have, it's going to return how many trees, and we'll pass in the storage for it, the location. All right, so then generate trees for horizontal, no, for corners. Corners first. Corner, let's go Y. Tree data C00, C01, C10, C11, tree edge data, edge north, edge east, edge west, edge south. I should probably put this in an organized order. Edge east, there we go. C00 equals generate trees for corners. Plus gen chunk size x. If anybody has any questions about what I'm doing here, please say them and I'll explain. Okay, so then gotta generate the, whoops. Gotta generate the edges. So the north edge is generate trees for horizontal edge, that's going y, and that takes C0, 0, and C. Wait, why are these numbered this order? This should be 1, 0, and 0, 1, which is backwards from how they're numbered when they're in arrays because the world is awesome. And that's all I have to write. And then the south edge, offset by gen chunk size y, and we increment the y's for both. And then do that order. West is 0, 1, no, 1, 0, 1, 1, no, 0, 0, 0, 1. Yeah. And then it'll be 1, 0 on the 1, 1. It's here. Which doesn't actually line up, so I need a lot of extra spacing, and I'm not going to bother putting it. All right, so at that point, we have all the neighboring things. So then we say add trees, equals 0. Add trees, address is C0, I guess. So I've been taking addresses out of all these. And we just want to add all those. 1, 0, 0, 1, 1, 1, edge east, edge north, edge west, edge south. And the reason I have trees called trees is because I brain node that one that has a comma before it is supposed to be num. Okay, so at this point, we built a list of all the trees just along the edges. So what we can do is just return that, not generate the trees in the middle, and see what that gives us. So we call generate trees for chunk with a bunch of trees. So tree location, trees, max trees per chunk, max trees per chunk. Chunk is gen chunk size x over min tree min spacing times gen chunk size y over tree min spacing. Is that right the right way? Yes. Num trees. Then here's generate the trees currently, so now we say num trees equals trees for chunk. Pass in trees, pass in x and y, and just comment out. I plus x off. Be not. Yeah, these are in chunk coordinate. Fair enough. So for I equals 0, I less than num trees. And base 3x is trees y dot x. Y. If bx so tx, which used to be I plus x off, now trees of is bx minus x. Ty equals by plus y. If tx greater than or equal to negative, what's this? Tx ty tx ty, and all that stays around. Okay. Do that. Never wrote collides. Okay. Collides. Do I have a bool? I forget if I went and added a bool. I did. SPH, do I have a bool? Tree area data. That's in Y. Or I equals 0, I less than 10. No trees. If absolute x minus add trees of I equal less than tree min spacing, or and absolute y minus tad trees I dot y. Why did that not autocomplete? Less than tree min spacing. Then squared test. So I should just compute these here. If fx times sx and well, plus sy times sy less than tree min spacing times tree min spacing, then skip this tree. Otherwise, no, then it collides. Return true. Call true. Otherwise, return false. Not define that. Okay. Yeah, I just don't know what feedback is the question how on earth that can happen? Like, I'm not sure what the actual question is. Raw. Oh, tree chords. Never wrote that. So, tree chords. So, sorry, I forgot to move my mic when I was sitting down. So, I mean, I have a historical perspective, which is probably not that interesting for somebody who isn't familiar with the whole answer. But I mean, it's how I think about it. So back in the old days, computers had one core and one hyperthread. And they ran computer, for example, at college, we used to have all these Sun workstations that people would work on, but they were not very good. They were 68,000 based, and area data, and so they replaced them And what they replaced them with were some Spark servers, which were at the time very high-end RISC processors. And then they just had the Sun terminals become dumb, what they're called X servers. They would just be displays that were just displaying bitmap graphics that were sent to them by the Spark servers. And we had a lab of 30 or 40 computers, workstations, and they were handled by 3 Spark servers. So what that meant was you would have 10 or 12 people logged in on a single server, and wow, it's totally impossible for me to talk about something unrelated while I'm coding. So each of those people were doing Unix-style computing, so they'd be running a shell, one or more programs at a time, etc. So you would easily have, 5 processes per person, and another, times 15 people all logged into the same server. And then you would have, some system threads doing various work. You'd have the email stuff running or whatever. So you'd easily have 200 threads, running on one of these servers. That only had a single core. So the idea that threads are in any way inhibited by the machine is kind of counterintuitive. Because if you know what a thread is, because historically a thread was just a time sliced share of the computer, and you can time slice it as fine as you want. They'll all get slower, but you can time slice it as fine as you want. Didn't write add trees. So so obviously the limit just becomes you can time slice time as much as you want, but other things you have to derive. So the biggest issue becomes in the memory usage. You need enough memory for all of the processes. And of course, you have virtual memory, so you can swap the process memory to disk. So you're not actually that limited. And this is tree area data. So the only real limit is that the memory usage of all of the threads. They don't all have to be in memory at the same time, so you're not actually even limited by that kind of thing if you have enough swap space. Now, having 10,000 threads not die when you try to run them to have them actually make forward progress, that's all up to scheduling and stuff like that about whether you can really make that stuff run efficiently. If you have 10,000 threads running and they all finish their work in a second, they each getting a millisecond of time slice or something like that, and they must have only had a millisecond of work to do. Now obviously in John's demo they just ran for a while and they were interleaving, they were printing out stuff to the screen, so a lot of the time those threads were blocked. He mentioned that the screen display was probably the slowest thing in it, and what will happen depends on the system is that each of those threads tries to write some output and they get blocked. They can't write any output until the data was interleaved, but only on a line basis. So there's something going on there. Don't know if that was a kernel system interleaving them or if that was actually in the thread space that they were locking against one another or whatever. So if you imagine they were locking against each other, one of them would lock the output and write to it until it hit a new line, say, and then unlock it. And so every other thread that tried to write to it would be blocked on that. But the way you think of that in the process world is that a process is often stopped waiting for I/O. It's waiting for disk or something like that. The kernel has said, it made a call into the kernel and said, I want this data. And the kernel says, I don't have that data for you yet. I'm putting you to sleep until I get that data back. And then the kernel can let another process run for a while. And this is why time sharing wasn't that bad, because most things weren't CPU bound. So you could run lots of threads and have them do stuff. And those interactive things, when somebody's sitting there reading Usenet, they're not using that much CPU most of the time. They're just sitting there reading Usenet and doing nothing. It's just blocking, waiting for keyboard input. So it's not as bad as it sounds. don't need that line anymore. Height lerp is still going outside of the box. That's not right.